Okay, because the first thing that we're going to do today is we are going to be finding square roots. And when they are, you use the second key in that key. And when we're looking for, so 100, so what I want you to be able to do is I want you to be able to find square roots when they're not squares we're finding them of. Nope, yours is this one right here. So that key, just press that, 100 equals. Okay, let's do it the other way around, 100. And then that key. There we go, you got it. Okay, everybody get their calculator figured out because you want to know how to do this, okay? So you need, you're going to do, yours is a 1, press the second key and then the square key. X, got that one first and then that, now 100 and then equals, okay? Now, so we just talked about a little bit ago that not all numbers are square numbers, right? Agree or disagree? Agree. Didn't we in fact come up with
Mr. Larson to Mr. Engelhardt's room, please. Mr. Larson to Mr. Engelhardt's room.
in fact, didn't we come up with a number that was not square? What was that one again? 9 times 8? 72. By the way, 18, is that a square number? Can you think of any number times itself that gives you 18? 9? 9 times 9 is 18?
9 times 2. 6 times 3.
6 times 3 is, but that's not a number times itself, right? Is there any number times itself that gives us 18? I don't think there are. So, not all numbers are square numbers. In other words, if you can't get, over here, I want you to look right over here. If you can't get an integer square root, it is not a square number. Well, here's an example. The square root of 3, we would have to round that one. Will you check that out in your calculator right now, the square root of 3? Does it give you a nice whole number, a nice integer value? Or tell me what happens if it doesn't. If you get something crazy like 1 point, whole bunch of places behind the decimal point, okay, what you're going to want to do on yours, you're going to get yours changed so I'll give you that. Okay, so so find if you can get it into what's called like a classic mode or something like that. Casio's, I never get along with those. I'm not really sure what it's like to do. Okay, so what we find is since every number is not a square number, we're not always going to get a nice integer value, so we're going to have to do some rounding, okay? Now, the calculator also does not tell you that there is that other square root for a number that I was trying to help you get before. So let's, you don't need your calculator at the moment. We got this without a calculator, but there is going to be a point we're going to need it. Let's start with number 1. The square root of 49. What's the square root of 49? 7, okay? But they say and, so there must be another one. Negative 7, because negative 7 times negative 7 is also 49, isn't it? Okay, how about 64? What would the square root of 64 be? 8 and negative 8. Now, be careful. Do not be misled and think that that means, because there are 2 square roots, that if I took 8 times negative 8, I would get 64. That's not what this is saying. It is saying if you took 8 times itself, you would get 64. If you took negative 8 times itself, you would get 64. So there are 2 ways to get positive 64, taking a number times itself. Okay, how about 16? Square root of 16, what would that be? 4 and negative 4. Okay. How about 1? The square root of 1. 1 and negative 1. 1 is its own square root, and the other square root of 1 is negative 1. It's opposite. Okay, how about 63? It's not a square root. In fact, here's kind of like a way to test it out. Which square number is 63 close to? 64. And 8 times 8 is 64, right? Well then, since 63 is just under 64, what's 7 times 7? 49. So doesn't 63 fall somewhere between 49, the square root of 63 has to fall somewhere between the square root of 49 and the square root of 64, because those are the square numbers on either side of 63. So somewhere, I'm guessing that if we now took the square root of 63 on our calculator, we better get, what's the square root of 49 again? 7. We better get 7 point something then, because 63 is between 49 and 64, so it's got to be between 7 and 8, right? Okay, go ahead and take the square root of 63 on your calculators now. And notice what it says up here, I highlighted it. Round decimal numbers to the nearest hundredth. Well, where's the hundredths place? The first, the second, the third, the what? Behind the decimal. The second place behind the decimal. So here's what we're going to do, you guys. We're going to go over here to the margin, and I want you to write down what your calculator says, just the first 3 places. I don't even care about the guys behind them, what they are, what they look like, anything. Just write down the first 3 places after that 7, after that decimal point. And that's what it should be. Do that over here in the margin. Because one of the things I find that students were not very good at is rounding. We're not really sure how to round, and we don't know what to do with those other digits and which of them we should use and how many of them we should use to help us round with. So if we're supposed to round to the nearest hundredth, I want you to underline the tenths and the hundredths place. Right now it is 7 and 93 hundredths. But we have to ask ourselves, is that next place value, that 7 in the thousands place, is it big enough to jump that up to 94 hundredths? Yeah. So we use this 7 to say, you know what? It's big enough to make this 7 and 94 hundredths instead of 7 and 93 hundredths. So rounding to the nearest hundredth, we use that 7 right behind that 93 hundredths and say, that's 5 or bigger. So I'm going to round up to 94 hundredths. What would the other one be then? Negative 7 and 94 hundredths, yes. So we have to know how to round correctly. Questions? Okay, then let's carry on. Number 6. What's the square roots of 81? 9 and negative 9. What are the square roots of 121? 11 and a negative 11. I should have made Kaylee answer that one. The square roots of 14. What 2 square numbers does 14 lie between? Well, would you bring your calculator out, because I want to test your knowledge here. What square number is a neighbor to the left of 14? 16? No, that would be to the right. So 14 lies between 16 and, Danny? No, 12 is not a square number, is it, class? Is 10 a square number? They're kind of nice looking numbers, but that doesn't mean they're square. What? 9. Oh, so 14 lies between 9 and 16 on the number line, right? Do we agree? And 9 is square, 16 is square, and there aren't any other square numbers in between there, are there? Okay, well, what times itself is 9? 3. What times itself is 16? 4. So the square root of 14 is going to have to be what? We predict it will be between 3 and 4. It's going to be 3 point something, right? Okay, let's write that. 3 point something right away, because we're so smart. Okay, now let's take the square root of 14 on our calculators. So second key and the x squared. Did you get it figured out?
Yeah.
Good, okay. Because you want to be able to get the decimal answer. And now put 14. Oh, there's a key you can just push to change it to a decimal. Good deal. So second, you don't have to hold it down at the same time. You just go second x squared. Type. Okay, then you put in the 14 first maybe on yours. I don't know, all we all gotta ever do is figure out what, okay, so I think what you're doing is the second key. X squared. When it puts that sign there, then you're good, okay. Okay, now you're gonna press this key, it'll change it to a decimal. This calculator, I know what it does, that one right there. Right above your enter key, press that, it'll give you the decimal name, okay? Anybody else still having trouble with their calculator? Okay, so you're gonna press the second key, the X squared key, and do 1, 4, and enter. And you're gonna have to press this key next to get it to change it to its decimal name. Okay, anybody else? Okay, so the first 3 digits, here's what I think your calculator should say. Remember, we don't care about anything past that 1. We don't even care, just drop them off, ditch them. Right now, in the hundredths place, we have how many hundredths right now? 3n. 3n. How many hundredths? 74 hundredths. Is this 1 big enough to make that 75 hundredths? Okay, so we're going to say 3 and 74 hundredths. And what's the other one? What? Negative 3 and 74 hundredths. Okay. So you're going to have some nice square numbers to find square roots of, and you're going to have some not square numbers. What will it do? Well, yeah, because you know what, it's not a square number, and what did we have to do? So we had to round, right? So when you have to round, it won't take you exactly back to 14. You are so right. It doesn't take you back to exactly 14, but it better take you something really close. Is 13.98 pretty close to 14? Yeah. Okay. It's because of our rounding. Okay. And she's getting the same thing. Same thing's happening to her. Okay, show me. Show me Kaylee taking the square root of 14, please. Okay. Okay, now press equals. Yeah, that's what it is. Okay. Okay, anybody else? Okay, so that's one of the things we have to make sure that we know how to do in our homework today, and again, for that test that will be coming up on Thursday. So no questions? You got this? Okay, now let's go work with the Pythagorean theorem. Anybody heard of that before? Pythagorean theorem, you've never heard of it? Okay, the Pythagorean theorem is a proof that says if you have a right triangle, what does a right triangle have to have? A 90-degree angle. It has to have one right angle, doesn't it? Okay, so if we have a right triangle, the Pythagorean theorem applies to it. And here's what the Pythagorean theorem is. I want you to just circle this nicely.
You don't have to.
Oh, well, jeepers, of course you do. Would you like the sheet so you know what, you can do what I'm asking you to do? Okay, thanks. Thanks for reminding me. By the way, you get another sheet, so you're probably have to remind me again. So, thanks for taking care of me on the last week's school. Okay, now would you please circle the Pythagorean theorem that says a squared plus b squared equals c squared. A squared plus b squared equals c squared. Well, now we got to make sense of what a, b, and c mean in a right triangle. So a and b are called the legs. Okay, so we're going to fill in that blank over there. A and b are called legs, and the legs make up the right angle. They are always the two sides that form the right angle. So why don't you put that little picture there too? So these guys, the legs, are the two that form the right angle, always, okay? No matter where it is, in which corner, where this is flipped upside down, whatever. The two sides that come together to make the right angle are called A and B, and they are called the legs. C is called, it has its crazy own name, called the hypotenuse. Hypotenuse. C is called the hypotenuse. And it is always across from the right angle, okay? So C is always across from the right angle. So this, here's our right angle, so we go across from it, there's our C. Okay? So draw yourself a little picture there, so that you're always able to understand the parts of a right triangle, so that you can use the Pythagorean theorem. Okay, so I have a picture here of a triangle here in the middle. It's right here, okay? So here's side A, there's side B, there's side C, okay? There's the triangle. And on coming off of each side, I have a little square that is the same side, has the same side length as the triangles that the triangle itself does. So tell me, how long is side A? How many units long is side A? Look on your paper. How long is side A? How many units long? 3. Yeah, it's 3 units long. So from, if I start at the top or I start at the bottom and I count, I get that A is equal to 3. A is equal to 3, not A squared. A is equal to 3. What's B equal to? 4. Okay, count. Make sure. 1, 2, 3, 4. And what is C equal to? 5. Notice its square is kind of on a slant there, isn't it? So 1, 2, 3, 4. It's 5 units long. So A is 3, B is 4, C is 5. But notice, this is something to make sure that we observe. If we just add A and B together, do we get C? A plus B, is that C? 3 plus 4, 5? No. So the Pythagorean theorem does not say A plus B plus equals C. It says A squared plus B squared equals C. So we have to square A, which is our 3. We have to square B, which is our 4. That's what we're going to add together. And in the end, we should get our C squared, which is, I'm writing awfully big for how I have these on here. I'll change all those. This is 3 squared, this is 4 squared, this is 5 squared. A squared plus B squared equals C squared. Well, class, what is 3 squared? 9. What is 4 squared? 16. And what is 5 squared? 25. Is this a true statement? 9 plus 16 is 25? Okay. So let's verify this with the area of the squares, because that's what it is saying. If you square the sides, adding the legs squares together, you should get the hypotenuses squared. So count up how many squares are there in that square. That's off of side A. What's A squared? 9. There's 9 little squares, right? Is that a 3 by 3 square? Yep, it's 3 long by 3 wide, and it forms a square with 9 units squared. How about B squared? How many are there? 16. 4, 4, 4, 4, that is 16. How about C squared? What's that? 5, 5, 5, 5, 5. How many? What's 5 fives? 25. So it is saying that if you have a square drawn off of each of the legs and you add up their areas, that should give you a square drawn off of the hypotenuse, its area. When you add together the legs squared, you should get the hypotenuse squared. So the Pythagorean theorem is a valuable theorem to help us with our third learning goal, which says I can use the Pythagorean theorem to find missing side lengths. So we're going to be working with the Pythagorean theorem the rest of today and then again tomorrow. So anybody have questions about the theorem itself? That's all we're doing here is kind of, making sure that it works. And we can see why it works. Okay, let's go to our last page then. Oh, you don't have it yet. Ha, you didn't have to remind me. in the end, you need to remind me to send staplers around for you so that we can staple these, okay? Okay, so now we are going to find a side length, and today they're going to specifically have finding C, the hypotenuse. Everybody get one? No? Short change, you guys? Okay, 7 more back. Okay. Okay, so we have this triangle right here. I'll highlight it. It's right here. There's the triangle. And this time I drew a square off to the side of A, and I drew a square off to the side of B, but I did not draw one off of the side of C. We're going to figure out what C is equal to. That's our missing side length, okay? So we're going to figure out how long is side A. Oh, they already tell us right here, don't they? So 6, this right here, this is really our A. Would you put 6 equals A, which we can read backwards, A equals 6? And our B is going to be 8, so B equals 8. And we are looking for C. Just like we don't know what C squared is, we don't know what C is either, do we? We don't know either right now. So let's put our A squared in, which is 6. So 6 squared. Plus our B, which is 8. That has to get squared. That should equal our C squared. Okay, what is 6 squared? 36, okay. Let's go verify over here. Does this have 36 squared? Could you count them up, please, and see if A squared actually has 36 squared? Yes, does it or not? It does? Okay, that's good. So A squared is 36, okay. B squared, what's 8 squared? 64, okay. Would you go over here and verify, are there 64 squares in this square coming off of side B? Farm up for me, I can't see it on mine, so farm up for me. Okay, yeah, are there? Yeah, okay. So, feeling pretty good about that. Well, if we put those two squares together now, if we added them together, how much would there be altogether? 100. So, our C squared is going to be equal to 100. Or in other words, the square that we would draw off of side C would have 100 little squares. So that would be kind of, you know, almost off the top of our page, almost, but not quite. So in other words, if we drew a square now coming off of this, we're kind of asking how long would its sides be? Because however long the side of the square is, that's our C, isn't it? So what do you think we have to do to get that? What do we need to know? We already know that that square that would come off of that side would have how many little squares in it? 100. Well, let's go back to these guys then. A squared, this square has 36 and its side length was 6. This square off of B has 64 squares and its side length was 8. So the square coming off of side C has 100 little squares in it. So how long would C have to be? What size square do we have? Okay, well then, since we're not grasping that, we'll do it the abstract way, which says, whatever you do to an equation, do it to both sides. As long as whatever you do it to both sides, you can get away with it. And why would I take the square root of C squared? Anybody know? Because that's the one I want to take the square root of, and if I do it to c squared, what times itself is c squared? What times itself is c squared?
C.
C times c, right? A c times another c is a c squared. So this is why we're going to take the square root of c squared so we can get c, because that's what we're looking for. And what's the square root of 100? 10. But there's also another square root, isn't there? What is it? What's the other square root of 100? You already forgot? Okay, go look at another page somewhere. No, 10 is the square root of 100. What's the other one? Okay? Negative 10. But can we have a triangle with a negative 10 side line? No. So in this case, it only makes sense that we use the positive 10. So right now we're saying c equals 10. So c equals 10. Because remember, c squared had to equal 100. Would a 10 by 10 square have 100 little squares? What's 10 times 10? 100, length times width. So we have a square that is 10 units by 10 units, making for 100 square units. So that makes side C 10 units long. So our answer here is this. Okay? Right here, circle that. Okay, let's try number 2. Okay, so the first thing that we're going to always do is write down the Pythagorean theorem, which is a squared plus what? B squared equals c squared. Okay. How long is our A? How long is our B?
16.
A is, no, A is not 16. How long is A? 4. A itself is 4 units, and then we have to square it according to the theorem. How long is B? 5 units. And according to the theorem, we need to square it. We don't know what C is. That's our question mark. Okay? C equals question mark, just like C squared equals question mark. Okay, but pretty soon we're going to be able to say what C squared equals. What's 4 squared? 16. 5 squared is 25. So that's going to be our C squared when we add those two together. What's 16 plus 25? Sylvia? 41. Okay, let's go up here and put that C squared equals 41. We now know that. Okay, tell me something about 41 in relationship to the fact that we're working on squares. Is it a nice square number? 41 a square number? I don't think so, but 6 times 6 is 36. 7 times 7 is 49. And 36 and 49 have 41 between them, so it can't be a nice square number. So what are we going to have to do? We're going to have to take the square root of it. So we're going to take the square root of 41, and we're going to take the square root of c squared, because that's how we get our c. And what are we going to have to do with that one? Well, let's see. What does it say in this one? Does it give us any directions about rounding? Nope. So since it doesn't, we'll just stick with the rounding to the nearest hundredth, like we were. Well, we can come up here and fill these in too. Maybe you guys already did. I just forgot to. So remember, when we do this, we go, okay, what are the first 3? Do we write down the first 3 digits after the decimal point? So this would be 6.4, help me out.
40.
0 what?
3.
3, okay. So right now, it's 6 and 40 hundredths. Is 3 big enough to make it 41 hundredths? No. So we leave it 40. We do not drop that 0 off and say zeros don't matter at the end. They do matter when we're rounding. So we would say this is a 6 and 40 hundredths side length. 6.40, saying that shows we rounded it to the nearest hundredth, not to the nearest tenth. Okay? So, does it make sense that it should be 6 something?
Yes.
Because remember, 41 is between what and what? The square root of, it's the perfect, between the perfect square 36 and the perfect square 49, and that would be between 6 and 7, and we ended up with a value between 6 and 7. Okay, so, you know, some loose leaf,